Yes, so welcome everybody. Um, we're going to talk about code reviews today. My name is Paco from Beckhoven. I've been working as a software engineer for quite a long time, mostly as a consultant, and since a couple of years ago I moved to Switzerland where I started working for a company called Hexagon. I work at the Innovation Hub and we work on a project called HXDR, which is a cloud-based platform that allows us to do a lot of cool things with 3D modeling, but we also sell map data of the whole world. All of that is not really important, but they're also the ones that give me the time to be here, so I always like to mention them at least. But what is important, and the reason why I'm here, is that I really like code quality. I like to talk about code quality, I like a good developer experience, and I like to spread knowledge about that. But that's enough about me. Let's talk business. So, $316 billion is not my salary, unfortunately. But it was the estimated cost of fixing bugs in 2013, according to a study by Cambridge University, and this included the time of finding and fixing bugs. Now, I add some inflation, you have enough money to solve a lot of world problems. So a lot of money is wasted on bugs. Now, one of the things, I don't know who's familiar with this picture, is what you often see is that the more time it takes to find a bug, the more complex it is to fix it, the more expensive it also gets. So the earlier you find a bug, the cheaper the bug will be, in theory. Now, one of the things we can do, for example, is, and what I want to focus on in this presentation, is code reviews. They take place approximately in the coding and testing phase, and it's at least a lot cheaper than finding bugs later on, theoretically again, but sort of to give a sense of urgency and why I would like to do code reviews. Now, what is a code review? So I found this nice definition, and I think it's sort of okay. It consists of three important parts, I would say. The first part is finding and fixing bugs, like the reason where you save a lot of money, frustration, reputation. There's also learning and coaching. It's a place of mentorship where you can learn from each other. You can also get people to get used to the best practices within the company, the mentorship I mentioned. And it's about improving code quality. And because I like code quality, I thought I'll give it a definition of its own, a rather vague one, but more or less it's about making code more readable, efficient, and in line with your company's or team's standards and code conventions and best practices. Now, these best practices, this all sounds pretty good, right? Yay, code reviews? Okay, so we don't want to see this. Now, of course, I updated the picture. I even added the asterisk to make sure I don't trigger too many people. But yes, nuances may apply. There's, of course, many different situations in which you could say, code reviews, we don't need it. Maybe we invest heavily in mob programming or pair programming. Or we have a team of so many seniors that have been working together for 10 years and they all know each other's trains, and we do a strategy in which we fix fast, fail fast. Or even better, you do the code review after deployment. Even that's a strategy that I've seen. It's interesting and it could work depending on the risks you're willing to take and the risk and the experience of the team. But in general, I would say code reviews is a good thing that most teams use, and well, let's see how we can improve it. Now, these code reviews, how do they come and play? What we always see is that they became part of the development process through, the code reviews became part of the development process through pull requests. You create a branch, you make your changes, and then you can ask for feedback. Now, I wanted to do a quick show of hands. Is it called a pull request or a merge request? So pull request, merge request, GitLab users? See, yeah. So GitLab is the one that mostly pushes a merge request. I have, unfortunately, also been brainwashed with GitLab for the past 2 years, which means I might intertwine the terms pull request and merge request, because to me, I also like pull requests, but I've been corrected too many times, unfortunately. I mean the same thing, they mean the same thing, just for your information. Now, these pull requests are facilitated by most version control systems. There's many out there, and they allow us to do this thing, the whole integration where you can chat, you can give feedback, you can give suggestions, they have tools that can interact with them, and I even add reports and all these nice things. And even though we have these great tools, we still often see the less pretty side of code reviews. For example, you have the pull request that super descriptive, and still manages to change 55 files in a project, and you try to figure out. And surprisingly enough, this is the one that gets usually the review within 5 minutes, if it looks good to me, and then, because why would we invest time in it, right? There's the great feedback that we get from people, but there's also the fact that we don't get any feedback, and we're just waiting. And the one that I also see often is, and it's still true, the curse of the small pull request. Because whenever it's a small change, then all of a sudden it's something we can easily grasp, so now we can nitpick about every single character that there is. So how do we address these issues? And I want to go over a couple of steps, and I think one part of the solution lies in creating review-friendly pull requests. TM, I think. So for this, we're going to assume that all the changes have been made, and the changes were concise, they were focused, they tested, and everything was done great, so we don't have to talk about the change, we're going to talk about the pull requests. One thing that I added here, and that I kind of like this quote, it's Robert C. Martin, which is Uncle Bob, right? Yeah, I was confused him. Which is the fact that we spend more time reading code than we spend time writing code, and whenever you write, it's more likely to be read more. It's going to be read more times. And this actually doesn't just apply to code. Basically, your pull request is similar, right? Whenever you create this pull request, this description, you write it once, but the chances that every reviewer is going to read it, and future you and future other people that were questioning what happened there are also going to read it. So it's worth to invest some time there. So let's start with a good title. Fix bug is not a good title. A good title should be like a good commit message. You want to add some context there so that it's at least clear what happened. But as I said, a good title should be self-explanatory, like a good commit message. Why not add commit lint to it? So you have this thing called conventional commits, which is sort of a standardized way to write commits in a certain format. The nice thing about doing this consistent, and according to a specific format, also with the way you write the verbs and everything, is usually these pull request titles make it their way to the commit message, and the commit message often makes its way into the release notes. And then it's nice to have something that enforces this to be consistent. So why not add linting? Also, then the nice thing about conventional commits, they distinguish, for example, between fix, features, patches, so you can immediately even do versioning based on your pull request title if you add this linting, which is, I think, pretty cool. Always include the Jira or whatever ticket referencing you have. Most VCS tools automatically turn this into links, which is also very useful. Now, okay, so we can actually talk already quite a bit about title. Now let's imagine how much I can say about a description. So a description, many things. I would say start with a context. Start with explaining basically the extension of the title. Anything you couldn't put in that one line. What should people know? Which things should they read? Where should they look otherwise? Maybe related pull requests, maybe related documentation. Then what? What did you change? Just give sort of the user what they can expect, a small summary of whatever is in this pull request. Maybe you did some extra refactoring or something that at least they understand. And of course, I'm going to say this is going to assume that maybe you should have done this refactoring in a different commit and a different pull request. But we also know that sometimes we don't want to do that, so we're going to assume we did it in the same thing, so it might be good to still announce that here. Why? And this is also often forgotten. When you're creating this pull request, when you go through this process of making changes to your code, you went through some thought process. You made choices. I could use this framework or this framework. I could have gone left or I could have gone right. This knowledge, write it down here, because it also helps the reviewer to understand, right, you chose this solution because of this, rather than that they assume, why did you not consider this? Then they will ask the question, then you can give them the answer, or just give them the answer in advance. Of course, there's many places where you could write down the whys. There's architectural decision records or Confluence page or anything. But if it's not documented in any other place, at least write down here the things you considered. Because it's in your head, so might as well write it down. And what I like, examples. Especially in front end, if you work in the front end, of course, it's easy to just add some screenshots of the before and after or whatever it is so that people can immediately see what the impact is. But actually, for backend, we can also do these things. If you add a new endpoint, you can add an example request and an example response, which makes it easier for the reviewers to test, and even for the testers to test. And even if you don't change something externally facing, if you make changes to the database, you can also add example queries and example response, or how to use this part. This all saves time, because probably you already went through this, you already tested it yourself, might as well put that request that you use for testing in there so that the other people don't have to recreate it. It's all about saving time and efficiency in the end. Now the challenge is to keep this concise and readable, right? Nobody wants a big wall of text, and most people also don't read a big wall of text. Add sections, emojis, whatever you can come up with, or actually ChatGPT is one of the things what it is kind of good at, is summarizing these things and making them more readable. But what also is a great solution is just use a template. Set a template in your version control system. Because if you have consistent places where the information is stored, that also means that people are more likely to find information, the right information faster. And what I particularly like about templates is checklists. They are a great place to remind people of things. Sorry? Never mind. Things that are forgotten. This could be procedures like, hey, architecture diagrams. Sometimes you make changes and you need to update some architecture diagrams. But it's usually only once every 10, 15 pull requests you make. A lot of things are just bug fixes. So you often forget, all right, I also had to do that. It could be procedures like, hey, don't forget to update release notes, or any things that you should be checking that you didn't automate yet, so that you make sure that it's done here, like, I don't know, the test coverage enforcement. What I also like is that, for example, you see here, changes are covered by tests. This is always a thing that sometimes people tend to take a shortcut. Do we really want to test this scenario? And now they're forced to check the checkbox, which is sort of, again, a mental reminder like, hey, all right, I should be writing tests, or am I going to lie? And of course, you don't lie, so you will have to write tests with a simple automation. It's so easy. Now, we create this pull request, but the next thing is that we're also going to be the first reviewer of our own code. Why? Because when you review your own changes, you look at it from a different perspective. You have a fresh set of eyes, usually, if you do it a bit later, but also you now focus on just the changes. You see just the diff, so you just see the place you change, and then immediately you might see that, hey, I made a change to this class, but actually there's no relevant changes in there anymore because I chose a different solution. Just revert the change in that class because it's noise in the pull request, or leftover renaming things, maybe typos, maybe some other parts or thing left over. But also then, I mean, besides fixing them, you can also add comments, and I think that's start practicing this and doing this because it's so helpful. I've seen it at least is add context to changes. Like if you have you made a lot of changes to a file, how do you find the essence? Like suppose I am fixing a bug. It's a one-line bug, but I also formatted the file because apparently we don't have automated formatting here. Now we have 20 lines changed, but only out of those 20 lines, there's actually one line that's very important. Just add a comment there. Hey, this is the actual bug fix. The rest is less important. Or I renamed this because of this. So that people don't have to guess. One of the things, for example, here, I removed the file, but before removing this file, I sort of did check in the Git history since when is this file unused. I did this research. I spent time on it. If I write it down, then the person reviewing it also doesn't have to go through this research. Just write a small note. Because there's not really, you cannot do wrong. As if you add too much information here, well, then they have to read a bit more, but it's quite useful. Also, you can use it to highlight important parts, like I mentioned with the bug fix, or hey, this part I'm unsure about, can you maybe help me? Like asking some questions. Or what I also have seen before is that if you have another team managing a certain library, and you're now going to use this library, or you're going to integrate with their services, tag that team around that change, so they immediately have the right context, like, hey, can you have a look at this? Does this make sense for the other team? So now we've done our best. We added a couple of comments. So anything that we would have expected of questions coming from our reviewers, we already answered before they could even question it. Save some time there. Let's get people to review it. We've seen before that it can take some time. People sometimes don't like to review. That can be because it takes them away from their current task, which means they will finish it slower. People don't like to switch context, or maybe they think they can't find it because it's this amazing godlike programmer that never makes a mistake, so why would I waste time going to understand it? Now you could try this, but usually this only works for a couple of times. So one of the reasons what you often see, so to get back here, the ideal world, teams proactively check whether there's open pull requests or round robin assign people. In practice, it's just a message that's thrown in the void of a channel that there's 20 people and then somebody might look at it. And the problem is that this whole shared responsibility usually means if it's a shitty task, nobody does it because we all think somebody else is going to do it. And the best way to address this is by targeting specific people. And even if you target the wrong person, they're very likely to target you to the right person quite quickly, and they're more likely to respond, because now I'm asking you to review it rather than anybody in the team. And what also helps to get a quicker response is to add some context of what the change is about. If I'm making a change in a specific place of a microservice, and just say, oh, I added this endpoint in this service, then people that are also working in the service might be triggered like, oh, hey, right, I'm working in that area. I should also be, that's interesting. Let's have a quick look. And a deadline, also quite useful. Just some sense of urgency. Is it something that is it's a very important quick fix or bug fix that needs to be reviewed today, or it's only or it's something that needs to be done by the end of the week? It gives some people to add it to the time, or it allows them to sort of put it in their schedule. So a message like this, where we target specific people, we ask them, we tell them about what it's about, and we add some sense of urgency, is much more likely to get an answer than the generic question, hey, can it please look at it? And the interesting, or actually these are generic practices. This is not just about asking for reviews. Whenever you need something from another team and there's a Teams channel and you need to ask something to this team, like, hey, can somebody help me with integrating? It's much more likely to pick a random person in that team, ask them, more likely to get an answer quicker. Now, people start looking at it, so we start also receiving feedback, which also doesn't always go as expected. And there can be many reasons for this. Some people simply lack the social skills. I mean, it's still IT. But it's also IT that also means it's very international, which also means we have a lot of different cultures. For example, I'm from the Netherlands. We're known to be quite direct, which sometimes can be interpreted as, well, being offensive. So that means that I probably know that I maybe need to add some fluff to my messages, or that at least the team is aware that this isn't not because I don't like them, it's just that I don't like their code and this is how I express it. But what is important is, and this is also what being a professional about, is being patient and trying to be the bigger person. And not meaning that you need to be right, but meaning that you don't let it get to you, right? It's about the content, whether it's personal or not. Doesn't matter, we're here to talk about the code, not about whether you like me or not. Now, there's also the fake feedback that you receive. It's quite annoying. Whenever you do this, you sort of have two options. You can either ask for clarification, which is a very good thing to do, because then you don't have to spend time going through the other option, which is sort of a trial and error, trying to figure out what they possibly meant, which is a waste of time. So whenever you see something that's not clear, ask for suggestions, ask for whatever they possibly mean, instead of trying to figure it out. Then what you see are the endless discussions, right? We've seen this and we've said it so many times, pick your own battles, you don't need to win everyone. If there's a battle that both parties think they should win, and you're at the 20th reply in a thread, which also sometimes happens, this might be a point where you probably should have thought, maybe I should just take it offline, start, go into a video call or in a room and discuss it. And then, very important, always report it back, and not just, oh, resolved, discussed, because we discussed offline, resolved. That's useless, because then the next person doesn't understand why. So always add, we chose X because of Y. Add some reasoning to it so that people also understand, and future you, because that's important. Future you forgot that conversation. So when you can go to the pull request, you at least can get back to the reasoning. Now then, last but not least, also try to be grateful, because people took the effort to go over your changes. They tried to help you, tried to improve things. Also thank them for it. If there's something new you learned, hey, maybe they have a great suggestion on a different framework or a different refactoring, well, show some appreciation. It can also be like the junior that just started, finally added some comments on your MR, and some actually make sense or are like, hey, great question. Make them more inclined to review more. It adds a bit of confidence, it makes it all a bit more friendly. And friendly message goes a long way, and more friendly, more happy people means more productive people. So always add some positivity, try to add some positivity. So now we wrote the pull request, we got the reviews. Now we're going to switch seats to the reviewer side. So we're going to be giving reviews. And I think the most important part about giving reviews is that you should review in a timely manner. Don't wait too long, because the longer you wait, the more time you have chances on merge conflicts, but also, or yeah, merge conflicts is still correct, or switching context. Like if you wait a week, then you still need to get back. Oh, right, I still have this pull request open. What was I doing here again? Why? So it costs a lot of time. Now there's two ways to address this, or two things that I usually like is, when you start a day, you're usually fresh. You're not having other contacts. So to prevent the context switching immediately, just start the day with reviews. Just spend the first hour doing reviews, unblocking people, so that you can then have more focused time on your actual work. The other moment is when you finish a task and you're going to pick up a new task. That's also sort of, you have to context switch anyway. Why not do a review? And there was one presentation that I attended. They sort of told, like, ideally your backlog is ordered by priority, which means that any existing tasks that are worked on have a higher priority than the next task that you're going to pick up, which means that theoretically, if it's ordered, you should first spend time reviewing those existing tasks rather than starting yet another new task, because that probably has lower priority. Then the other thing is, it's about taking responsibility. So what I think, and what I've seen too many times, is that that pull requests became a formality. Like, right, I need two approvers, right, I click the button, and you need somebody else to click the button. Rather than, ideally, you want somebody to look at it. You want people to take responsibility. In the sense that when you make a change, you should become a co-owner. When you review a pull request, you should become a co-owner of that change. You should be signing it off, which also means that whenever something goes wrong in this pull request, or it introduces obviously bad things, people should be also asking you and keeping you accountable for the fact that it went wrong. Not necessarily in a blame game, but, well, maybe a bit, because apparently you didn't put the effort of reviewing it. But it's the mindset. It's about, when I sign this off, and if it goes bad, then I'm also responsible, so I should spend time on making sure that I did my best to prevent anything that's in there. Now, when we start looking at the code, the first thing that you should do is read the description. I've been Sheldon many times where I just dove straight into the code and then wondered, why did we do this? And then before asking the command, I always go back to the description, and then usually there's the answer. If you just were to start writing commands, the most frustrating thing is that we just put a lot of effort into creating this nice pull request with lots of descriptions, and now we realize that people actually didn't even look at it. It's kind of wasteful. Now I need to answer a comment. Just read that there. It's there. And the same also for existing comments. Why would you have to answer the same question twice? Just put in some effort, get the context. It also helps the reviewer to get his head into the context of the change that are going on. This, by the way, also goes two ways, right? So if there's no description, and it's fairly poorly described, ask for clarification. Because there's one thing that's very wasteful, it's trying to reverse engineer from just the changes, what actually the intention was and why certain things were done. So rather than starting review, just ask somebody to can you please write down a description and I'll have a look later. Because it's a bit a waste of my time to try to figure out, especially if it covers a lot of files, that there's no instructions. Then when we start looking at the code, where do you start? It's always, it's very easy to dive straight into the code and start talking about the constant that should be private instead of public. But it's much better to start at the top. Because the reason being that if there's changes in design, things in the design that should be different, that will trickle down on the code itself. So those commands about that public constant are usually, that constant might even be removed because it's going to change anyway. So when you think the design, the high-level overview, the functionality is put in the right place, you start looking at, is the functionality correct? Is the functionality complete? Did we miss some happy flows or unhappy flows or certain scenarios that could occur? Then we can take a step further. We can look at, okay, so the functionality is in the right place. It seems to make sense. Let's look at the complexity. Did we pick the right algorithms? Did we do it in the right way? And then, and I'm going to repeat it twice, we're going to look at the tests. We're going to look at the tests. Because tests often get the least amount of attention and love during implementation. They also get the least amount of attention and love during reviews. The reason being that through alphabetic sorting, usually the test files are at the end. We've looked at the implementation. And yeah, we already spent so much time on this, and the implementation looks good, so test should be good, right? It passed. But then still, there can be many missing assertions and many things that can go wrong in the tests. Spend time watching the test, because this will in the end affect you, right? If there's assertions missing, and I've introduced plenty of bugs that were there that shouldn't have been there if there would have been proper regression tests. But because somebody was too lazy to assert all the fields and just asserted that one field, the ID, that they thought was important. Yeah, so look at the assertions, look at the tests, make sure. And then we can start looking at anything we'd like to nitpick on, like the public constants. Are there typos in the Java doc? Anything that is sort of the least important thing, but still important-ish. Now there's tools available that can help you with this. Like I mentioned before, the version control systems, they actually have quite some nice features. Now the one I by far discovered last year like the most is code coverage. In this case we use GitLab, but other tools use it as well. So just who uses code coverage in their diffs, in their version control systems? Yes, great. It's so helpful because the alternative, because when you review, you want to make sure that it's tested, right? So you want to check if it's tested. You don't want to go into the coverage report and then have the coverage report in one hand and the code style change in one hand and then putting them next to each other. Seeing in the diff is so powerful because you can immediately spot parts that are untested. Or in some cases, I had a change where, of course, the person making the change should look at this as well, but sometimes they don't. Then you can still point out, hey, you added half this class is untested, and then it turns out from a previous solution could have been removed. There's so many easy things you can win. Another nice tool integrations that you have are, so for example, with SonarCube, which can already do like half the work of the reviewer when it comes on the nitpicking part, so you don't have to do that. But the best tool of them all that I have yet to see beaten is your own editor. For multiple reasons. So suppose we take this small change, not too important, I would say, but for the sake of my demo, of course it is. If I would look at this from my editor, now I immediately see, hey, there's more context to it, right? That constant is now in use. You couldn't see that from just the diff. When you open it in your editor, you immediately start seeing things like the unused constant, or the fact that maybe this equals should have been and is empty, maybe a bit nitpicking, but sure, improvement, or the fact that if we don't have the test coverage in your VCS tool, you can still have test coverage in your editor, and you can immediately see, hey, this line is untested. Ah, right, so it should have been tested. And the nice thing is that these tools also show you, like IntelliJ shows you which lines were actually changed. So if you look at classes from while the branch is open, you can immediately see, okay, it's nice to know where to look at. So use your editor when you do review other people's changes. I find it really useful. It's much easier to navigate. Most VCS tools offer an online editor as well. At least I know GitHub does and GitLab as well. And it can be quite helpful. Then, of course, we're going to find things, or we might find things. I want to give a couple of tips related to writing good comments. And the first one, what I learned when I started focusing on it, is the use of the word you. You did something wrong, you chose this, you should have, you forgot, you shouldn't. You can be interpreted sort of, it feels like an attack. Whereas if I talk about we, it's more about a collaborative ownership. It's about doing things together, collective ownership and collaboration. It sounds a bit fake, but if I say, and we doesn't have to be correct, right? I didn't make those changes. He did. But if I say we, because in the end we are all building this thing together, it sounds much more, people are more likely to willing to cooperate because they don't feel personally attacked. Then the other thing is that you have statements. You can say, hey, this is wrong. Hey, you should have chosen this framework. You should have used this library. Or you should have used these flags. If you turn that into a question, the first advantage that you have is that if you're wrong, you don't look like an ass. Because it's likely that you're wrong, because you don't know the reasons. Maybe somebody chose this and they actually have a good reason. So if you ask why did you set these certain flags and not, you can add a subtext later. But that also allows people to either give you a good reason or they come themselves to the same ID. and when they have the same ID, of that ID themselves, they're also again more likely to improve and cooperate. So it's all about the chances of getting your changes through and getting people to cooperate. So something like this is much more likely to get a response. And so both these techniques change the tone drastically, which is usually really helpful. Then also try to be specific. I've seen it too many times that there should always only be one interpretation possible, and ideally. That's also why I think reread your comments, at least for me a best practice. This also goes for Slack, anything that if there's 3 possible interpretations or just 2, there's a 50% chance that it might be interpreted wrong and time is wasted there. So just reread your comments. It sounds so simple, and yet it's sometimes so often missed. And what also helps is it's very easy to say that something is wrong or you don't like it, but it's actually kind of hard to also come up with an alternative or solution, but still try to, because it's always easy to say it's wrong. And then you leave sort of the person who making the changes there. And now what? So it can help them forward. Then there's this great tool feature that we also have is the use of suggestions. So what you can do in most VCS tools is that you can select a couple of lines and then in line make changes. In this case, changing equals to is empty, or what you can do is usually typos in Java docs. The nice thing about this is that it's twofold. The first thing is that the person who makes the changes cannot interpret it wrongly because it's there. You can click the button, apply suggestion, it's up there, and then it's done exactly as the reviewer intended. And the nice thing is that the reviewer now doesn't have to go back to the code to check if you fix it correctly because he clicked the button. It cannot be. It's exactly as you want it. I really like this feature. The only caveat is if, for example, you remove a class or a field, usually you also need to remove imports. So they click on apply suggestion and then the build fails because of unused imports. But I mean, just a bit of sanity also works. What I've also seen, I thought it was interesting, I think it's a bit extreme, but conventional commands. So we have conventional commits, but there's also a way to make, to standardize commands and pull requests. You could give it a go. I gave it a go, and sometimes it's interesting. It looks kind of nice. But what I did particularly like about this is, or what I think is most important, is the nitpick tag, or making sort of the urgency of whatever you try to tell clear. And the nice thing, for example, you can make within your team, you can talk about what do we do with nitpicks. And one of the things that you often say is, it's up to the person making the change to decide whether or not they're going to actually apply it, but they are free to resolve it whenever they want. So it's sort of a suggestion, but feel free to do with it. And I kind of like it, because then at least you make sure that it doesn't block any pull request or there doesn't block any discussion. Then last but not least, praise. Again, we also did it when receiving the comments, try to find positive things in the pull request. Maybe it's something simple like, hey, they tested it properly, you're very happy with the feature, there's countless of positive things if you practice this to find. And the nice thing about it, usually, right, these pull requests are not necessarily the most positive place, but adding some compliments usually help. It doesn't even have to be at the end in a commit, but also like at an implementation, like, hey, oh, cool, I didn't know about this framework. Nice. So it adds a layer of friendliness. People are more likely to cooperate if there's also some friendliness in there, and it's clear that they're not there to just destroy you, but also appreciate you. And it also helps boost people's confidence. And especially if you see in a time of imposter syndrome and people always being more and more insecure because you always see that better developer, it kind of helps them realize that they're also good developers. So the tone, the positivity, which again, everybody more happy, people more productive. So we covered the code review part, but there's one more thing that I wanted to cover, which is bike shedding. It's a common thing that you see in pull request land, or this is what you see common in the Netherlands. Bike shedding, also known as the law of triviality, is basically we give too much attention to trivial issues. What you saw was the small pull request and the big pull request. Or in this example, the story is about a committee that have to discuss this power plant, but they spend way more time discussing the color of the bike shed of their office because that's something easy to comprehend. So we waste time on the trivial issues even though because it's easier. For example, well, it's a different example, things like this. If it's dot equals or if it's dot is empty, in the end, it doesn't really matter, does it? But for the sake of consistency, we make these commands. But they also add a lot of noise. And the problem what I've seen is, so first of all, it distracts the reviewer from the bigger picture because they keep seeing these annoying little things. But also you have, and assuming the bad intent of people, there's people that sort of look at changes and then see, yeah, I added some comments, I'm done. So we don't want to help them, we want to find things. I don't have a lot of time, so I'm going to be slightly quicker here. I want to go over some tools that are really useful. The first one that I really like is error prone. It's a compile time tool that can find common mistakes and bugs, and I suggest automated fixes for it, or apply automatic fixes. It's originally created by Google, but there's Picnic, a Dutch online supermarket. They spent a lot of time also creating a lot of rules to sort of make their code base consistent, and they open sourced it. And to give you some examples, say you can filter a list in two ways. You can use the address is not null, or as it says the suggestion here below, did you mean list.filter and use objects, : non-null. They do the same, but if you just do one way and you have a tool that automatically fails if you don't do it the one way, then you don't have to have this discussion in the pull request. Big decimal .value of 0 or just big decimal .0, or when I introduced it, I find some occurrences of broken logging, because if you use string.formatted, you should use %s and not accolades. And for logging, it's the other way around. I never understood why we just didn't make this consistent, but it can go wrong. But I also found broken assertions. Anybody knows what's wrong here? It's a nasty one. Yeah, so nothing actually happens here. The assert that is from Hemcrest or assert j, and you need an dot is equal true is true or is equal to at the end. But because the equals is in the middle, this does nothing. And this is something that the tool then says, hey, did you mean to add is true at the end? It's quite helpful. It already fixes an assertion just by introducing a framework or sorry, a tool. So what I did, what you should do is, there's a lot of rules in them, and some, like Picnic, was very biased towards, for example, using Google's immutables. I'm not sure if it was Google, but immutables and some other libraries. You might want to disable those rules if it doesn't match your companies. But just good to start with the whole set and tailor them to your needs. Create a couple of example merge requests and then pull requests, and then fix it there. What I did encounter, or one of the lessons, if you also use Lombok heavily and you start getting into the dirty things with super builders, there you might have some issues and you might have to disable some rules because they don't play along that well. But in general, it's still super useful. Then there's Open Rewrite. It's an open source library that allows you to do large-scale migrations. Why does this affect in the context of a code review? What you often see, so this tool helps you to, for example, easily migrate your whole code base from Java 17 to 21, to go from old switch statements to new switch statements, Spring upgrades, and actually, if you do any of these things by hand, stop and start looking at Open Rewrite because it's so incredibly useful. JUnit 4 to JUnit 5, for example, just rather than having to go over hundreds of classes, it's just one thing. But within the context of code reviews, what you often see is that, oh, hey, can you also immediately, can you use the new statement? Can you please, while you're changing this file, can you also fix it? Just fix it in one big go, and there's no noise and pull requests on old versions. But the biggest one, adding a lot of noise in pull requests, is often formatting, the way you formatted things. Hey, can you add this line break? Or hey, you forgot to format this. What I often saw when I joined the company was that we had sort of, so the first step is to get a formatter, then to have everybody in the same formatting settings, and then to enforce it. So we were at step 2 and we missed step 3, which means that my standard way of looking at pull requests was check it out in my editor, compare with branch develop, format the files, paste the number of changed files, paste the changed files in the pull request, and I did this every time. It's a waste of time, right? Because they can also do this. So first thing, make sure whatever code style you have, that is automatically enforceable. And there's different ways to do this, but it's best to just stick to industry standards. That makes your life a lot easier. And one tool that I like, because it's extremely strict, but also comes with a cost. Well, so the nice part is Google Java Format is a tool that just there's only one way to format things. Technically, there's two, I think, with tabs or spaces, but that's it. That's the things you can configure. And that's how you deal with it. It means that there's no other way, and it's super opinionated. Any line break anywhere will be reverted. There's, of course, tiny exceptions, but in essence, there's no more room for discussion. And yes, this also means that sometimes it does things suboptimally. And yes, when it's super opinionated, people are less likely to like it in the beginning. I also couldn't convince my teammates to use this because it was so different from what they were used to that I had to solve this with check style rules. But the problem is we always go from, especially I've been a consultant, right? You go from one job to another, and every time there's different code style, and every time you don't like the new one until you get used to the new one, and then you don't like the new one. And this is a constant circle. Just take the pain once, get used to it, and there's no more discussion, there's no more noise, it's automatically formatted, because no format will be perfect anyway. Now, one of the tools that also kind of nice with this is Spotless. Google Java Format isn't actually a Maven plugin, but Spotless is. And the nice thing about Spotless, it actually also has formats for many other languages. And the thing is that in practice, we do actually have a lot of languages in our projects. It's never just Java. There's also SQL often for the migration scripts, maybe some configuration. There's lots of them. And if you have a look at Spotless, then you can actually immediately cover all of them and make sure that they're all consistently formatted. It's also really nice. I briefly also mentioned check style. You can use it for the formatting, like we had to do, but there's also some other things like constant name should be uppercase or match a certain pattern. What you see is method ordering. You can also enforce with check style, like you always want the constants on top, or you want public methods on the top. Ways to enforce this so that you don't have to be bothered about this in the pull requests. The last one, Arch Unit. What I really like about Arch Unit is that it's so this one runs as a test and allows you to sort of enforce architectural guidelines, something that all the other tools are less good at. Arch Unit is also used for Spring Modular for those. More of a fun fact, actually. I'm not at the Spring conference anymore. But so there's these architecture checks. There's a nice DSL that you can use that sort of say, hey, all these classes that in these packages should not depend on classes that are in these packages. Like if you have the classic MVC or, well, in this case, controller services persistence, you should not go from the controller directly to the persistence, and persistence should definitely not talk to the controllers. And it's very easily enforced with a couple of things in a simple test that can be put in a generic library that can be shared. What I also liked is the naming conventions. So we all have a convention for interface, and we all have a different one. One says I at the start, the other said interface at the end, the other say we don't want to change the interface name, we add import to the implementation. It doesn't matter, and we shouldn't care, but just pick one and stick to it. And this is a nice way to enforce that so that you don't have discussions about it. It's always interface at the end, done. No more discussion. Or with controllers, the nice thing that I saw is that you can, controller should be postfix with controller, but you can also say each controller should be annotated with @secured, so that each public method and each controller should have security checks on it. It's a simple way to sort of make sure that it all fits a certain standard. Now, there's already a large set of predefined rules. I would say check this, use this to capture your common mistakes, and mostly also create a shared model that you share across all your microservices. When you introduce these tools to your organization, it's good to start small. There's a lot of tools in there. Don't just apply them on everything, but take it small and show examples. Take the team with it. So what I did is, for Airpro, for example, I created a couple of example merge requests, pull requests, for certain repositories that we had, and then for each change, I sort of referred to the rules in Airpro that were used. And then there we could have a debate on whether or not we would like this rule or not. So that everybody was sort of on board. And if there's a lot of people that don't like it or don't agree with it, you disable it. That at least you can get them started, and then later you can maybe enable it. But at least there's less resistance. What we also did as Picnic was we had discussions. And if there was a new rule, and then we started a discussion on Slack, and then a poll at the end, and then everybody could vote. Then to conclude, so write descriptive pull requests, review them yourself first, then be specific in your communication, but also be friendly and positive. use these VCS features in your editor to help you review, and then last but not least, stop bike shedding and start automating. And that's it. Thank you.